Well, hey everyone. I'm Zach. I'm a staff developer advocate at Pinecone, and I'm joined today by Hassan, who's developer advocate at Together AI, and we're very excited to chat with you today about taking AI applications from POC to production as quickly as possible.
Yeah, thanks for the intro, Zach. Hey, everybody. Welcome to the webinar. I saw Rob in the Q&A asked, I thought this is taking RAG apps from POC to production fast. It is. I think we might have had the wrong slide or on the title slide. So yes, this is taking RAG apps from POC to production. And I'm here to talk about an app I built and that I scaled to about 20,000 users. So I'm gonna just talk about the app, talk about the architecture, talk about how I used RAG in my application, and we'll just answer questions as we go. So hopefully it'll be a nice introduction to a RAG application kind of in production with real users. So I'll share my screen and get things kicked off with a quick demo. All right. Share screen. Okay. So this is what the website is called. You can go to it right now if you want to. It's pdf-to-chat.com. It's currently live right now, and this app basically helps you chat with your PDFs. So the idea is that you sign up, you upload a PDF, and then you can begin chatting with it, and it'll use RAG to grab context from the PDF to answer your questions. And it's also open source, so you can check out all of the code on GitHub, which we will be doing as well. So I'm going to go ahead and log in. I have login implemented with Clerk, which I really enjoy for this. So it lets us log in with Google, and we hit our dashboard. So these are a couple of our PDFs that I've uploaded before. We can upload a new one. I'll just go ahead and upload a new one to show the embedding process. So I'm going to re-upload Fahrenheit 451, which is one of my favorite books growing up. And so this is kind of a big PDF. So it might take a little bit of time. It's maybe 300, 400 pages. But you'll see it gets uploaded. Now it's being ingested. I'm going to go over the ingestion endpoint that I wrote, which basically uses LangChain to take a PDF, break it into chunks, embed them on Pinecone, and kind of have them ready so we can run RAG on them and kind of ask questions using that PDF as context. And so I'll show an architectural diagram kind of the whole app and how it works as well. So it makes a little bit of sense. So we'll kind of give that a second to go.
Hassan, if I can ask a question while we're waiting here, if we're going to give a high-level overview of folks that might not have heard about it before, what are embeddings? Like when we're taking some data, passing it through an embedding model, like what are we getting out? Where do we put that and why?
Yeah, absolutely. So when you take data and you put it through an embedding model, it returns basically a list of vectors that represent the semantic meaning of the text. And the reason we want to do this is we basically, you can almost think of it as taking the PDF. Like I guess the very simple alternative here is taking a PDF and just storing that whole PDF in a database and trying to search through it. But the issue is a lot of the semantic meaning is kind of lost when you do that. Okay, actually, a lot of the semantic meaning is lost when you do that. So when you embed something and you actually give it semantic meaning, what you can do is when a user asks a question here, you can embed that question as well and run a similarity search to kind of find the most relevant chunks in that embedding and use that to answer the question. So we're going to take a look at that whole flow as well. So that should hopefully make sense. But this is the app, right? So we have this PDF on the left-hand side. You can kind of scroll and read it like you would a traditional PDF. And you can also ask it questions on the right-hand side. So we're going to ask it, what temperature do books burn at? And what it'll do here, it'll take this query, it'll embed it, and it will try to find the most relevant chunks in this whole PDF and answer it. And actually, it'll also cite its sources. And it uses an LLM from Together AI called Mixtral. I work at Together AI, by the way. And it cites the sources down here. So we can see it says the combustion point of paper is 451 degrees Celsius, Fahrenheit. We can click on any of these links and it'll actually take us to page 194 here. And it shows us like where it kind of got that information from all of these different sources, which is nice. So yeah. That's kind of the app in a nutshell. You know, it helps you run RAG on it. We're gonna just take a look at more specifics in a second. And I see people already asking like, what tool and library did you use to like parse the PDF? I use LangChain, and we're actually going to look at the code in one quick second. So this is the app. You know, I kind of launched it a few months ago, and I'll show you the analytics as well. It looks like I've had about 25,000 visitors since then. It kind of peaked when I launched, and lately it's been doing like 4,000 visitors a month that are kind of using it because it's like a free and an open source app. We can actually also take a look at the database to see, because every document that's uploaded, I kind of stored in the database. So we can run npx Prisma Studio. I use Prisma and Postgres as my database, and Prisma is just kind of a database connector that also gives you a nice like preview environment to see your database. So we can see that I have, actually, let me go over our schema really quickly. So I'm going to go to my Prisma schema, and we can see it's very, very simple. All I have is one table called document, and this document table contains the file name of the PDF that the user uploaded, the file URL, and when it was created, and the user ID. Just so I can kind of store that information, just so that when people log into their dashboard, they can see kind of all of their PDFs and everything is kind of stored there. So let's go back to that Prisma screen. And we can see that we have these documents, and we can see we have 9,318 documents, which means there's been a little over 9,000 PDFs uploaded. We can even click on them and see like file names and see what kind of PDFs people have been uploading, and something about SaaS companies and rules for life. Someone uploaded their resume, some Bitcoin stuff. And so there's like an infinite amount of just not infinite amount, there's 9,000, but there's a bunch of PDFs that people have been uploading, which is pretty cool. So yeah, and it's scaled up very well. So despite, you know, all this usage, it's been really, really great to run. So that is essentially the quick demo. I am gonna dig into, I'm considering either going through the architectural diagram or going through the code first. What do you think, Zach?
Architecture would be awesome, but maybe right before we do that, let's just so what you've demonstrated here is that like unlike traditional search, you issued a complex query in natural language, like what's the temperature at which books burn. You may know that that's in the book or not, but what's extremely powerful about the system is that it comes back immediately, thanks to the fact that we've embedded it, right? And so like those embeddings are the preferred way that machines like to deal with the same semantic structure. And so we're really like getting to the heart of the user's query immediately. And that's what makes RAG so powerful in this app, like so awesome to use, right?
Exactly.
Yeah, this is pretty powerful for, and as you said, like the fact that it's even just open and on the internet now and anybody can start using it, getting insights out of their PDFs quickly is pretty powerful.
And you'll see if you ask it a question that it doesn't know, and we'll look at the exact prompt, it tells me that like, hey, we can't provide an answer for this, which is really cool. So that it doesn't like, for the most part, it tries its best not to hallucinate. Obviously, this is AI, and you can't avoid that after a certain
Yeah.
point.
Yep. And
Yeah.
also, again, just in case anyone's not aware, like what are hallucinations? And then like where does RAG fit in with that, I guess would be the other question.
Yeah, great question. So hallucinations are basically when you ask an LLM a question and it responds with the wrong answer, but it responds confidently with the wrong answer. So you don't actually know it's wrong. Obviously, that's probably the number one issue that LLMs have. They're super cool that in that they can kind of show you or give you answers to kind of anything, but they do hallucinate sometimes, and so there are kind of techniques to dealing with that. So obviously, with RAG applications, like the simplest technique to dealing with hallucinations, or to at least minimizing them, because you know it's very, very hard to bring that number to zero, but to decreasing them is in the system prompt, which we'll take a look at in a second, that I'm using for this application. I kind of say like, hey, like do not use anything else other than the context provided, right? And then I do my vector search call, and I grab the most relevant paragraphs and I put it into that prompt. And so I try to make it as much as possible. I try to tell the LLM to, hey, like please only use these four like chunks, because I'm doing it with four chunks for me. So yeah. So all right, there's a lot of questions in the chat. Maybe I'll do like a rapid fire really quickly, and then I'll get back to showing the architectural diagram, because I think that'll answer some of the questions. So Luis asks, what's the metric you use to be sure you have the right answer? That's a great question. So those are called evals, and it's a little more advanced. I don't have evals set up for this application yet, but I have a PR in progress, so I can show off a little bit
That'd be
there.
awesome. I
I'm
can
into
also, Oh,
Yeah, go
sorry,
ahead.
Hassan. I'll also just share that we just released a chapter on RAG evaluation, which I'll drop in the chat in case that's relevant for folks too. It's open source ebook and answers a lot of those questions.
Amazing. Amazing here. I'm gonna ask, what LLM are you using? So I'm actually, great question. I'm actually using Mixtral. So Mixtral 8x7b. I'm probably gonna switch to Llama 3 though, since that came out. So I am currently actually in the process of running some evals on Mixtral versus Llama 3 8b versus Llama 3 70b to try to compare a bunch of different LLMs and see how well they do. What PDF tool do you use to scroll and render on the UI? Great question. So I use a library that I'm gonna show in a second because I'm gonna show off the front end. Someone asked, can we use Olama or Phi or another LLM with this? Absolutely. You can use whatever, you can kind of plug in whatever LLM you want here. In my case, I'm using Mixtral through together.ai. Okay, looks like there's a bunch of other questions, but I'm just going to move on for now, which is great. This is great. We'll definitely get to the questions later on. I'm going to try to just draw a super quick diagram of like kind of how the app works, right? So we have PDF to, oh, okay, this is way too big. All right, so we have PDF to chat. PDF to chat, zoom in a little bit. This is the whole application. So basically, you kind of start with the landing page, and then you go to like sign in, and I use clerk.dev. It's really, really great. Gives you the ability to just drop things in and pick your kind of method of authentication and kind of log in really quickly. So that's kind of what I use for sign in, and then you kind of get into the dashboard. So in the dashboard of the app, I have a lot of things going on here. So I have like, so this is the dashboard. We're going to say like we have, like, first of all, we're displaying all of the PDFs that the users uploaded. So display PDFs. And this is like a Postgres search, because remember, I'm using Postgres to store all of the users' information. So I display all the PDFs from Postgres. I also give the people the ability to upload PDFs. So the thing I'm using for uploading is this company called Bytescale for uploading. I use S3 under the hood, so it's like Bytescale/S3. That's what I use for uploading and actually storing the physical PDF. And so after a user has uploaded a PDF, what I do is I call an ingestion endpoint. So we're going to take a look at this because this is an endpoint that I have written. The app is built in Next.js, so we'll take a look at some backend functions in a second. So the user uploads the PDF right here, and then at the same time, it runs through our ingestion endpoint. And our ingestion endpoint kind of has a few different things that it's doing. Number one, it's like parsing the PDF and breaking it into chunks. So it's kind of one thing that it does. Another thing that it does is after breaking it into chunks, it embeds the chunks in bytecode, because I need to store them somewhere with a namespace. So we're going to talk about the namespace thing really quickly after as well. But it embeds it in Pinecone, and it stores it in my database as well. So stores the PDF and user info in the database. So this is kind of all it does. It takes a PDF, it parses it, it breaks it into these small chunks, and then we embed the chunks. We actually embed them using like the Together embeddings endpoint. So we have an endpoint at together.ai to actually embed different things. So I run it through the Together AI endpoint, and then I embed it inside a Pinecone with a namespace, and this is how I kind of delineate users. So that's kind of what happens here for the ingestion endpoint. So after we kind of go through the ingestion endpoint, what happens here is we pass it through to that page that you guys saw right over here with the kind of the PDF on the left-hand side and the chat on the right-hand side. So when it gets passed to that page, actually, I'll add this in. So let's say we get the like individual PDF/chat page, right? And so after we get this page, people can then chat with it and send it chat messages. So then, when someone sends it a chat message, we actually will call the chat endpoint, which again, I'll cover. So there's two main endpoints in this app, or in the kind of in the back end. We have the ingestion endpoint that takes the PDF and ingests it into Pinecone and ready for us to kind of run RAG on it. And we have the chat endpoint that will kind of use, it will kind of like define the system prompt It'll like take the user's query. It'll like it has a whole like retrieval system. And this retrieval system will like query Pinecone for the relevant chunks and use them as context. And Zach can talk more about that.
Can I just interrupt and ask a question, a clarifying question? So by the time we've hit let's say we've hit the ingestion endpoint in a given workflow, what we're saying then is that the user's PDF has already been chunked into semantically meaningful chunks. It's been passed through an embedding model. We've got the vectors out of that, and then we've stored them in Pinecone. So we've essentially what you've done is built a knowledge base already by this point, right? In which now the chat endpoint and the user together can interact with that knowledge base, and that knowledge base can retrieve the context, which we're finally going to pass to the LLM. Is that
exactly.
roughly correct? Cool.
That is absolutely right. That's absolutely right. So yes, as Zach said, by the time we get here to this page, we already have the vectors stored in Pinecone and ready to be queried. So absolutely. So at that point, the chat endpoint, right? Like we define, our like system prompt and a bunch of other things. We define, we take the user's query, we use the retrieval system, in our case, like Pinecone, where we query Pinecone with the user's query, and we try to get back the relevant chunks of text. And then we call the LLM with like the full context. And I'll go through yeah, so this is technically kind of how it does. And then, obviously the LLM responds with the context, and it responds with the sources as well. And we'll go over how I actually pass in the sources too. So this is kind of a very rough overview of the app and kind of how it works. This is the GitHub repo. Obviously, all the code is here. We're going to go through some of this code. So as I said, just to re-go through the tech stack really quickly, I'm using Next.js for the full thing. I'm using Mixtral as my LLM through Together.ai. I'm using M2BERT for the embedding model through Together, and then storing on Pinecone. We use LangChain to kind of do a few different things, which I'll cover. We use Bytescale for the PDF storage. I'm using Vercel for hosting, and for hosting the Postgres database as well. And then I'm using Clark for authentication, and Tailwind for styling. So I think we're ready to dive into the code.
Do you mind if I ask one more question while you're showing the PDF viewer? Because I want to point this out to folks. What's really also insanely powerful is that the fact that your app is bringing back citations, right? We talked about how RAG can address hallucinations, but it can also provide additional confidence, especially if imagine if you're going through either medical or research-based journals, and you need to be positive that the response is correct. You can go view those citations yourself and double check them, right? And so that's like a really key piece of some of the value that the RAG pipeline brings, is that sort of auditability for the human in the loop, if you will.
Absolutely. Yeah, so we can ask it, who is Clarice, who I think is a character in this book. I haven't read it in so long, and I just said my favorite book, but yeah, it tells us about her a little bit. It kind of summarizes a little bit of what she does. She lives next to the main person behind this book, Guy Montag, and blah blah blah. And obviously, like Zach said, like you don't have to trust this. Sometimes LLMs are wrong, right? So I can actually click into these pages, and if I wanted to really be sure, I can click in and I can read these pages, and I can read like where they talk about Clarice. So yeah, so that's also something to explore for sure. Okay, awesome. So there's still a bunch of questions in the chat, and I'm conflicted on whether to answer stuff. Maybe we'll just go through the code first, and then we can break for a little bit and answer.
Yeah, I'm gonna try answering a couple while you're doing that as well.
Amazing to hear. Okay, so all right, let's dig into the code. All right, so I'll open up VS Code, and we'll dig into the code. So this is a Next.js application. Like I said, the way Next.js applications are architected, they have this app folder, and a lot of these routes over here are my front end, and then I have a couple of my backend API routes over here. I'm going to zoom in a little bit so you all can see. So we're going to cover the backend first. Remember, we talked about the chat endpoint and the ingestion endpoint. These are the two endpoints, and we'll start with the ingestion endpoint. So let's go through what I'm doing in here. So what I first do is I initialize Pinecone using the Pinecone library. I make sure I have the right environment variables, and I grab the file URL and the file name from the front end. So this gets sent to the from the front end, because remember, this route is called sorry. Yeah, so this ingest PDF route is called after the user has uploaded their PDF. So at this point, we have the user's PDF. We have the user's, like the file name and the file URL of the PDF. So I get that. Here, I just run some authentication. I'm just making sure that whoever is calling this endpoint is actually a user of my application, and not someone who's trying to who's trying to call an endpoint randomly. I make sure that the user does not have more than 3 documents. That's one way I kind of limit things a little bit on my end, because obviously the app costs money to run and it costs money to store these PDF documents and everything. So I do some rate limiting to make sure people aren't uploading more than 3 PDFs. And then I create the document in Prisma. And that's kind of what we saw in the database, where we saw all of the names of the PDFs and the URL and the user IDs. And then what I do is I grab this this user ID this is a randomly generated ID from my database. I grab the ID and I set my namespace to that. So this is kind of how I separate things. This is how I know if, again, there's 9,000 PDFs across several thousand users. This is how I know if a specific user logs in and clicks on a specific PDF, that this is how I know how to look up context just from that PDF. Is I use namespace to kind of separate those PDFs. So this is where it actually starts. So what we do is we get the PDF. This is the PDF is the file URL, right? So I get the response, I put it inside of a buffer, and I use this PDF loader function from LangChain, which is actually really cool. It helps you kind of it helps you read the PDF and parse it, and also split it into chunks, which is really, really important because you want to embed small chunks. So in this case, my chunk size is 1,000 characters, and I have 200 characters of overlap with each chunk. RAG tends to work a little bit better when you have a little bit of overlap from what I've seen. So after I split the text into chunks, I am creating my vector store. Well, yeah, I'm creating my vector store, but really I'm passing through all of these chunks of text. They're still text, right? So we need to kind of transform them into vectors to store them in the vector database. So what I do is I use the Together AI embeddings. I pass in my Together AI API key, and I'm using M2BERT. We have a bunch of embedding models, but this is kind of our flagship, most powerful one. And then, yeah, I just create an index on Pinecone, and I pass in all of those embeddings into Pinecone to get them embedded with the specific namespace as well, so that I can tell them apart. And if we go to our, I can go to my Pinecone dashboard, and I can show that like I have all of these records that are being in there. As you can see, I have 391,000 vectors, again, coming from 9,000 PDFs. So there's obviously several vectors kind of per PDF, and we can kind of query. In this case, I'm querying. I think I might have been querying a specific namespace. I'm not too sure. But yeah, you can.
Do we want to give a quick overview of namespaces for folks? Like they're a really useful feature if you're building multi-tenancy apps, like Hassan has done here, right? And you can see that even at high scale, it's a very convenient sort of primitive to be able to say each user gets their own namespace. For example, if you have multiple customers, each client or customer could have their own namespace. Then you can write 2 namespaces and query from them, which also significantly speeds things up a bit. So they are suitable as a segregation tool for data, and they're also suitable for and considered a best practice for efficiency of queries as well.
Yep. And here, if I click on namespaces, I can see I have a little over 6,000, and each namespace has a certain number of vectors kind of inside of it. So yeah, so that's the ingestion PDF endpoint. At a high level, takes in a PDF, breaks it down into text, sends those texts to our embedding endpoint to get them translated into vectors. Because remember, vectors that's how we look up the semantic meaning of something, right? Like if there's a PDF about coffee, right, that just constantly talks about coffee, and I ask a question, and in my question I ask about lattes, like if I'm just storing the PDF as text and it searches latte, it's not going to be able to match it to coffee. Whereas with embeddings, it will be able to do that. With embeddings, it'll actually take the meaning of latte and meaning of coffee. It'll understand that, oh, like these are pretty similar. So I should probably use the coffee chapters to answer a question about lattes. So that's kind of maybe a little bit of a stupid example, an oversimplified example, but that's an example of why these embeddings are so powerful and why we shouldn't just store just text. We embed them and then store the embeddings. And it's also and obviously something like Pinecone is explicitly built to store these vectors and be very, very, very efficient in order to make several calls and to scale really well with this. So that's the ingestion PDF. Yeah, like Bear said in the chat, the PDF is not stored in Pinecone. It's just the vectors from the PDF that are stored there. The actual PDF is stored in S3, so on Amazon. So, and yeah, thank you, Zach and Bear, for all the answers in the chat. So with
And
that said,
Hassan, sorry, do you mind if I just
yeah,
zoom
please.
back? Partly also because this is one of my favorite frameworks, but just for folks that might not be familiar, one of the reasons this is so awesome that you were able to build such a fully featured app, right, as a solo talented developer, is because Next.js allows you to do both front end and back end code, right, together in a single project. And then it's like purpose built and designed to deploy on Vercel, for example, which is a front end cloud. So we're also finding this, for what it's worth, to be a very powerful application stack for AI, not least of all because Vercel now has like the AI SDK, but you'll also see a ton of Pinecone examples that are built with the same framework in a similar manner. And so as Hassan's talking through this code, think about like there's the front end that we're all seeing, but there's also the back end. And that is critical because there's secrets here that are, you can see there's API keys being read out of the environment. And that's what the back end is essentially doing, is the heavy lifting with embeddings and inserts to the database and reads.
Absolutely. Yeah, Next.js has been great for building these full stack AI applications. So yeah, like David's kind of asking about how I store sources, and as Bear said, like we do store metadata that which I'll actually show in this endpoint. So that's actually a great segue into this. So there's a lot going on in this chat endpoint, but I'm going to kind of cover it kind of briefly. So what we basically have is we have our system prompt over here that we're defining. So we're telling it, hey, you're a helpful AI assistant, use these pieces of context. So we're telling it that we're going to be passing in context. Obviously, this context is variable. It's gonna like basically this context, what's being passed in is what's actually being fetched from the retriever later down the line. But we're kind of, pasting in these XML tags to tell it like, hey, you're going to get context. We're also being very clear of like, hey, if you don't know the answer, just say you don't know. Because again, we talked about how LLMs hallucinate a lot, and you kind of, you kind of have to try a lot of different techniques to stop them from doing that. So we're very explicitly like, hey, do not try to make up an answer. If the question is not related to the context, just say that like you don't know, or that it's not related, and here's the context, answer the question with the context. And I just ask it to return the answer in Markdown, because I'm then formatting the Markdown with a library called React Markdown. So this is kind of my overall system prompt that I use. And then we have the answer prompt here that, again, a lot of these are a lot of this is just a LangChain functions, but basically the answer prompt basically takes in the system prompt, and it will replace the kind of the context inside and answer with the user's chat history as well.
So
So
can I ask, like, just to tie it together a little bit, if you go up to that context, like this is where like the rubber kind of meets the road with the RAG retrieval system, right? Because that context that you've got set up in that prompt is going to be the results, the retrieval set from the vector search that you did, right? So like user's natural language query comes in, that gets vectorized and searched against the vector store. The context that comes back is now, as you can see in the actual prompt, the exact data that the LLM is going to be asked to use to answer the question.
exactly. And we'll actually show this in action because I have observability on this application with LangSmith from our good friends LangChain. And so I'll actually show a full walkthrough of how it grabs the context and how it pastes it in here. So yeah, essentially I have some code here that grabs all of the messages from the user, because we actually store all of the messages, which is actually kind of a cool concept. Like in the chat, not only do I get the user's latest query, I get all of the user's questions, and I have to format them and pass them into to the prompt. I'm defining my LLM model here. I'm using Mixtral, and yeah, we define our vector store again. We define it with a specific namespace because, again, we want to point it to a specific namespace so it knows, okay, like here's the namespace. We again define our embeddings, our Together AI embeddings endpoint. And the reason we do this is we want to take the user's text and we want to embed it itself. Like that's the easiest way to actually search things through in the database, because you can imagine like we're getting text from the user and we have this database over here full of vectors. And so the easiest thing to do is to use an embeddings endpoint. An embeddings endpoint basically will take text and will output embeddings or a vector or like an array of numbers. Actually, a really easy way might be to go through the to go to the docs that we have and just look at our embeddings endpoint docs. This is in Python, not JavaScript, but essentially, you put in some input, you select your embedding model, and you get these list of embeddings. I don't know if I have a full, yeah, like this is what it looks like. It's just a bunch of like a huge array of vectors or numbers. And so what goes on here, the reason why, again, we're passing this in is a user asks a question, we're embedding that question itself, and then we're kind of running a similarity search between those array of vectors and the array of vectors that's kind of stored in the database. So, and then, oops, I scrolled down a little too much. And then here we just have a bunch of LangChain chains that we're connecting together, and we're defining our retriever. It's a little bit hard to explain the detail that goes on in all of this, but we'll kind of go through the whole RAG pipeline on LangSmith, and I think it should make sense a lot more. One thing I do want to call out here specifically is that is the sources. So when I actually embed things in Pinecone in this over here, Pinecone will also store metadata, which is actually really cool because I don't even think I explicitly define and ask it to store metadata. It just stores it, which is so awesome. And what happens is part of that metadata is like the page, the page ID and the page, like the page number from the PDF. And so that's our reason why I can have those sources, as we saw kind of back in here. The reason why we have these sources is because I store the metadata. So when it actually fetches the answer, so again, this RAG pipeline, right? Queries Pinecone, I get back the 4 most relevant chunks. And those 4 chunks, I get back their metadata as well. And their metadata contains what page number they're in. So it's really cool that we can get that. And so I basically, I get those sources from the metadata, and I pass them in as a header. And the reason we do this is because I want to stream the response in. So I stream the actual response from the LLM in, so the user can kind of see that. Very nice, and it's kind of good UX overall. And at the same time, as a header, I send this X sources as a header, and these are my sources. And so after I'm done streaming the results and showing the results to the user, I then read in this X sources header from the front end, and I display those 4 sources. So yeah, those are our main 2 chat endpoints. I'll go through the front end super quickly, or go through just the front end, this front end page, where you see the PDF on the left hand side, because some people are asking, what library I use for this PDF. I'll answer some of those questions as well in here. So we'll go to the document and document client over here, and we'll go through how this works. So basically with this code, a lot of this stuff is defining the PDF. So here I'm actually using a library called @react-pdf-viewer, and it comes with a bunch of different plugins. And so you'll see that we have like a download or an open, or like these are just all options inside of the PDF viewer, and then all the way down in the text, like here's where I define it over here. So I put it inside of a web worker because apparently you need to do this, and then I render the PDF as a viewer over here, and I pass in the file URL that I get, so it actually shows stuff in, and I pass in the plugins from down below, so people can navigate and people can have a couple of controls on here. So it's actually kind of nice. If I go back here and I scroll, or I just, oops, I'm gonna reload this page. Okay, so over here, you can see we have controls. I can actually go to page 50 over here, or I can zoom in and zoom out. I can actually click this to have the PDF just be full screen if I just want to read it. I can download it, or I can print it, or I can show like multiple things, or rotate it, or have this hand tool and go up and down. So it's kind of nice, actually. It's like a fully built-in PDF viewer with all this functionality, which is really nice. So that's kind of the left hand of the screen here. Let me scroll up a little bit. So again, this is all stuff for the PDF viewer, like we saw. And then we have this use chat function. And for those that aren't familiar, there's the Vercel AI SDK, and that's kind of what I'm using here. And it's a really nice library to kind of let you build a lot of these AI applications and connect your front end to your back end. And so here I'm specifying that, hey, this is the endpoint that we want to call the chat endpoint, which we just looked at, and it gives us a lot of really cool things. It gives us like the messages from that endpoint, and it gives us a lot of stuff to handle like React state, and to handle like if a user presses enter to call this this backend route. And so it handles a couple cool things. And then also here on response happens after this thing is run. We get the sources, like I said, and I save them in a piece of state as well. So at the end of this, we have our messages object, which is a list of like what the LLM actually returned from the chat endpoint with the context, right? So I have the LLM's response in here, and I also have the sources for messages in here as well in this piece of state. So what I do is all the way down here. On the right hand side, I if a user hasn't asked a question, if messages.length is 0, I say ask your first question below, which I think is what it says right here, because we haven't asked a question. But if we ask a question, and why is he important? If we ask a question, it'll kind of return with a response. And you can see it streams in the responses, and it waits at the end, and then it shows the sources down here. So this happens with
sorry, Hassan, do you mind if I just ask you real quick? Like that's a really critical piece of the UX for users, right? It makes it feel alive and like you're getting it back immediately. Like, so what would happen if you hadn't gone to the extra work to do streaming, which Vercel makes a little bit easier? What would happen?
Yeah, if we didn't go through that work, what would happen is if you put in a question and you would just stay waiting for 10 seconds, 20 seconds, however long, it takes to end. And then, like Zach said, there's just this horrible UI experience because so many people are used to streaming now. Like it's become table stakes. And so that's why I kind of separate things in that way and send these in the header as opposed to just sending an object with like this like all the answer as one key value pair in the object and the sources as another key value pair. Like I choose to stream this stuff in and send this in the header so that we can actually stream and get this really nice user experience. But yes, thank you for calling that out. Yeah, and that's it. This is basically what we do in the front end. We map through these messages and we display them here. And for the user's messages, we put in the user's profile picture, which again, we got because they sign in from Google, and we have their profile picture from that, from Clark. And then the message content we actually put here under React Markdown, which is really nice because it'll automatically format this stuff as long as it's in Markdown. And we do kind of return in Markdown as well. So, and then again here we just display the sources, we loop through them, and we show just the page number because we actually have a lot of stuff in the sources. We can go to Pinecone and we can see that in here. So if I click on a specific vector, you can see this is the metadata that I get. And see, there's a lot of stuff in here. We get that it's a PDF that we uploaded. We get that this chunk is literally from line 6 to line 19. It's really awesome that it even shows in the line, so that theoretically, like I could have like instead of just showing the page number here, I could have it so that you can click the page number and it even highlights the chunk, right? It highlights the lines. So they're like, you can kind of go further and do a lot of cool things there. But yeah, it gives us a lot of stuff. You see someone uploaded a PDF about from Simon Sinek, who I think is like a productivity guy. Oh, they uploaded Start With Why, which is I think one of his books, and it's like 271 pages. So you get a lot of information from Pinecone metadata, which is really nice. So yeah, that's about it. That's kind of the whole application here. Like this is just some more data to handle the chatbot at the bottom, right? The chat over here and this button. And that is essentially it.
That's terrific. Thanks so much. Yeah, it's really a beautiful app, and it's awesome to see that even with the high scale usage like that, you're getting such like snappy performance too. Very cool.
Yeah.
We had a couple of really interesting questions. I wonder maybe we should tackle some of these together. Like, what would you need to do if you wanted to support very large PDFs, or if you wanted to allow users to upload more than 3? Like, when would you start to have scaling concerns, and what would that look like?
Yeah, that's a great question. I don't know that I would do anything differently. I think like if I was allowing users to do really long PDFs, maybe the ingestion might take a while, right? And so this ingest endpoint might take a while. And for me right now, I'm hosting this using Vercel. So everything is kind of serverless. So you can think of everything as like a serverless function or Lambda function. Theoretically, if someone uploaded maybe like a 2,000 page PDF it might take a while. And
Yeah.
you actually have to take that into context because a lot of the time serverless functions, they're meant to be short-lived. And so they spin up really quickly and they spin down. And a lot of them
Hmm.
have a default timeout. Like if you
Yeah.
are actually using Vercel and you're using the free plan, I don't remember what the timeout is, maybe like 30 seconds is the
Yeah.
timeout for serverless functions. And
That's
so a
right.
2,000-page PDF will probably definitely take more than 30 seconds. So it'll cause your serverless functions to crash, so it won't work. So, you'd have to go and maybe change the serverless timeout, or you would have to, yeah, think of different techniques on how to handle that.
Yeah, I think you can get to on the pro plan. You can request if you set a const and export it, you can get up to 5 minutes runtime on a serverless function. But to your point, we that
Yes.
might be the place where I'd start to feel like it's getting into the territory where we might consider a queue, right? And then like dividing up jobs essentially.
Yeah. Oh my God, Titus reminded me. I am using not LangGraph, but LangSmith. I forgot to
Yes,
show
let's talk about that.
the thing really quickly. Yeah. So just sorry to interrupt real quick.
Go for
We'll,
it.
I think I have it open. So we'll just open uh, LangSmith and we'll go to our project. Yes, thank you, Titus. I appreciate it. I did definitely mean to show this. And so LangSmith, for those that don't know, is like an observability and evals tool. I'm not using it for evals yet, but I'm looking into that very soon to kind of compare different LLMs, or you can compare different retrieval strategies and kind of see like that, oh, like this retrieval accuracy is this retrieval method is this percent accurate versus that percent accurate. So it's really nice for the evals. We actually have yeah, right now I just use it for observability. So I can see that like, okay, over the last 7 days, my P50 latency has been like 4.5 seconds. So that's the average time that it takes to for a user to kind of get a response back. And I ran 3,397 queries in the last 7 days. So I can actually click on them and we can click and see one of our queries. So what's cool about LLMs is, you can use them in different languages. So you can see people using Arabic and people using French in here, and a lot of stuff happening. So this is all from today. This is all from 5.8. As you can see, yeah, so this is from like 5 minutes ago. Someone is running something. It looks like it might be crashing because it's still running. But anyway, let's look up one of our queries. So I just did this query called "Who is Guy Montag and why is he important?" And it actually, what's cool about LangSmith is it shows us this entire chain and how it works. So we can click on each of these things. So we can click on the retrieve documents. So this step to retrieve documents took, almost a second. And what it did is we can click on all these document formatters. There's four. So basically, this vector store retriever is called, and it kind of uses all of these four documents as context. So you can see each of these documents. Let me zoom out a little bit and show this whole thing. So each of these documents I have metadata that's passed in, and I have the page content that's passed in. This is the chunk that's embedded. So for this question of who is Montag, it determined, that this was one of the most relevant chunks. We have this. So this is coming from page 159, and then we have this piece of context from page 125, and then this piece of context from 281, and then this piece of context from 162, right? So we have these four things, and they're actually all being passed into that context in our system prompt like we saw before. So this is our full prompt. So again, our system prompt that we saw in the code, and then we have the context, and then you can see all of the four chunks are passed in. Here's chunk number 1, here's chunk number 2, here's chunk number 3, and chunk number 4. So really all that the LLM sees is this whole thing. It doesn't care about retrieval, it doesn't care about any of that stuff. It just takes in this whole prompt with all of this context, and it also gets sent the user's query over here. Who is Guy Montag? Why is he important? And here's the output that it cited. So this is kind of the full overview of how something like this could work. Again, a user asks a question. We go through this retrieval chain where we try to find the four most relevant paragraphs. We find them. We get their metadata as well. We pass it into our prompt, and then we pass that into the LLM to actually answer the user's question. How did I integrate with LangSmith? Good question. Yeah, there's a PR. Actually, the LangChain team helped me with this. So there should be a PR on adding LangSmith. Update dips use built-in. There's I think it was part of a larger PR, but yeah, relatively simple. Relatively simple from what I saw. Yeah. But you can probably check out their docs. I guess I don't have I thought I would have a standalone PR to show it. I don't have that. I'm not using
So
LangGraph.
as we, also Hassan, as you and I were chatting about the other day, like this sort of tree diagram that LangSmith is giving you is incredibly powerful, right? Because even as you saw, like even as an experienced developer, there's a lot going on. But here you actually can see exactly each component and what it did and the steps. So that is a huge boon to debugging these systems, essentially.
Yeah. Yep. It's great for debugging. It's great for seeing, what part took the longest time. If, the overall query is taking 20 seconds, why is it taking 20 seconds? Is it a problem with the LLM? Is it a problem with yeah, it's really nice to debug all this stuff. Someone asked where these traces are stored. So this is LangSmith. Yeah, this is LangSmith. So it's just stored on their servers or something. I have my project here and I can kind of see all of my traces for all of my yeah, I can kind of see whatever time period I want. I saw a couple, yeah, there's definitely a lot of other questions. Some people were asking, so Titus asked, how long did it take me to build this project, and did I use AI to help build or code it? It took me, so I usually build this stuff on weekends, for the most part. So for this one, I think it took me maybe 2 or 3 weekends to build. And also keep in mind that I have built a lot of these types of applications before. Oops. Yeah, you can kind of go to my GitHub and see that, like, yeah, I've been building this stuff for a while. I have a lot of AI applications that I've built. This is probably my like eighth one or ninth one. So I did, reuse a lot of stuff. I did reuse like clerk, like I've done clerk authentication a million times. That takes me like 20 minutes to do with a new app. So it's stuff like that. So I think as you get the muscle for building these apps more and more, they just become easier, which is great. And no, AI didn't help me make this app. I
We
didn't
talked
really
about that
use.
yesterday. I can confirm that we discussed exactly that. And I also recommend, I've done programming in a bunch of different paradigms and languages in my career, and I really, really enjoy the Next.js stack. And I think there's a reason why you're seeing a lot of these like cutting edge AI apps being built in Next.js and on Vercel. And like I mentioned, Pinecone's also got a bunch of open source templates that are similar. But yeah, credit to Hassan is also a very experienced and talented developer, so we can't really get around that. There was a question in chat about, is this fully managed yet? It's no. I want to be clear that it's still an app that you built, right? It's composing multiple services that are fully managed, but you still need developers for this right now.
Absolutely. I saw Masood asked two quick questions. So one, can a user upload documents in conjunction with an already uploaded library of documents so that the chat kind of references the whole existing library of documents as context? Absolutely. Yeah, I can configure, a way to do this where a user uploads multiple documents and they're all uploaded to the same namespace, for example. So as long as I pass in that in the same namespace ID, it can refer to 5 PDF documents or 50 PDF documents or whatever the limits that Pinecone actually lets you store, which I'm sure is a lot. So yes, you can definitely change the application to make it so that the chat doesn't only reference one PDF document, but multiple, or maybe the user's entire dashboard. Maybe you have an option where you can toggle and use your entire dashboard. And then the second question from Masood was, do users always have to upload documents, or can they stream data from an external data source? Do you want to take this one on, Zach?
Oh, I was sorry. I'll let you do that one. I was actually going to ask you. Multiple folks now have asked what the monthly cost is to run, so maybe we do that after.
Yeah,
Um,
yeah, yeah. So I'll answer
yeah,
this question real quick. So
yep.
basically, he asked if users always have to upload documents, or can they stream data from external data sources. So yeah, you can kind of configure RAG however you want it to be configured. And so as long as you actually store that data in a vector database, whatever it is. It could be from a user's uploaded document. It could be whatever it is. You can kind of use that as context, or you can do more advanced stuff like use agents or function calling to actually call like a web search API if someone searches about current news versus using. Yeah, there's a lot of cool stuff you can do. But yes, point is all those things are possible. So yeah,
Oh,
Zach,
yeah.
you
What's
asked.
the rough? A bunch of folks are curious. Like, what's your
Yeah.
kind of back of the napkin cost right now, even with the usage that you've seen?
Yeah, that's a great question. I don't have those numbers, unfortunately. I pay for Vercel Pro. So but I don't have the cost breakdown for this exact project. I would estimate maybe like, so Vercel Pro is $20 plus extra usage. I don't think I would have really hit extra usage with the projects and how it does. So hosting was $20 a month for the CI/CD kind of as well. The Postgres database I also hosted on Vercel, and I think they do charge some money. So
Dollar a month now for a new, yeah, because I pay them like $32 a month, and it's like I have like two Postgres databases, so it's a dollar each per month now.
yeah,
Not
dollar per
bad.
month, but then plus usage as well. So there's definitely some cost there. Maybe $5 or something like that. So maybe $5 a month for the database, let's say. So it's like $25 a month. S3 will probably also charge you another $5 or $10 for that amount of documents. So let's say $10 from S3. Clerk will also charge you for users. Like Clerk, thankfully, like sponsored and gave me kind of a free account, but you would have to pay, I think, $10 per thousand users, and so I would probably be in the $50 per month tier. And then the LLM costs as well. So things really add up. If I had to pull out a rough estimate randomly, I would probably say like $200 a month is what I would pay if I was actually paying. Again, a lot of these companies thankfully gave me the services for free, knowing that like I'm not making money from this and it's free and it's open source and all of that. So I kind of got, free authentication from Cleric, free LLM calls from Together, all of that kind of stuff. Um, Great. Okay, Titus asks, what are you most excited about making in the future with AI models, frameworks, etc.? I'm most excited by applications. Like I love applying, generative AI to real applications and not necessarily working on, I mean, my company makes AI models and hosts them together AI, and that's great. I love using them, but I love using them to accomplish other things. I have a bunch of other random projects. I have like Room GPT where you can upload a picture of your room and get it redesigned. And this one actually has a couple million users. And it's crazy to me that like an app that I built in like 2 weekends can actually scale up to that amount. And yeah, I just love building this kind of stuff. So it's a fun time.
What's your outlook in the future? You excited now as an application builder that's empowered by AI? Do you have trepidation of any kind, or what do you think?
Very excited. I think we were talking about this yesterday, Zach. It's
Yep.
just it's such an exciting time to be a builder right now and
Yep.
and to learn this stuff and to just there's so much out there that you can build, and the more you build, the easier it becomes and the more things you can build, and it's just it's pretty phenomenal. There's so
Yeah.
many industries that I think can be impacted by AI and yeah, improved.
Awesome. Yeah. Nice job. It looks beautiful. Great job with the app.
Thank you. Cool. Um,
Somebody asked real quick. Titus asked if I want to point someone to become a builder, what are some good end-to-end tutorials, resources to recommend? Next.js and Vercel I think are very accessible. They've got great docs. I know Together AI. Do you guys have open source examples in addition to all of the wonderful TypeScript applications you just shared on your GitHub?
Um, I don't think we have that many TypeScript examples in addition to that, but yes, I think Next.js and Vercel is a great place to start to understand how to build full stack applications. Because
Yep.
honestly, most of the work, like it's crazy because like these are AI applications, and you would think that like, oh, you probably spend 95% of the time on AI. And it's like, no, I spent most of my time on the front end for this application to actually build it out, to design the
Yep.
landing page, design the dashboard, to make sure the chat looks good, to I played around with so many different PDF viewers to actually find this one that actually works well. And so I actually spent the vast majority of my time building this project on the actual, front end, and yeah, maybe 20% of the time on the actual like AI. So
Yep.
that's interesting.
That's what's also so cool, and I agree, like echo your sentiments. It's an amazing time to be a builder because this insane power is being kind of commoditized behind APIs that we're already super familiar with, and we're getting additional support from providers like Vercel, where, as you saw, it's baked into the stack now to be able to call those as a first class citizen. So you're sort of like, if you're a developer now, you're sort of only limited by your imagination, essentially.
Yeah, absolutely. I see a couple of questions in Q&A. Maybe I can go through them super quickly. We have a couple minutes. Is that cool? Okay. So Sebastian asks, how did you resolve the first spike of users in your app? Did you experience any downtime? I think he's referring to like when I first launched, I got a bunch of users. I actually didn't experience any downtime, which is great. because I was averaging like a couple thousand visitors a day. Pinecone scaled really well. I had a pretty sizable pod, so it was doing great. And I think there's Pinecone serverless now, which I think is even better and will probably scale even better and make it so that you don't, like, even if you run into limits with your pod, you don't have to go and manually upgrade. But yeah, thankfully, like everything was kind of like Vercel was kind of serverless, and all of my other services scaled really well. So no downtime there. Um, a couple people were asking on, like, yeah, how do you get the page of the paragraph that it's embedded in? Like I said before, it's just metadata from Pinecone, so I know exactly like what's being stored, which is nice.
Oh, maybe
Um,
I'll just quickly touch on that because there were questions about
yeah,
metadata. Metadata, like think of it like an arbitrary JavaScript object that when you're upserting your vectors, you can define whatever fields are useful to your application there, right? So in Hassan's case, maybe it's page number, PDF, like the exact location. And Postgres have done that in a recent app. You can put whatever you want there, and then when you retrieve those vectors, you can use or introspect the metadata to do whatever you need to do in your application. And then certain providers, including Pinecone, even support search based off of that metadata. So we can do what's called a hybrid search. And provide metadata as filtering. We call it metadata filtering.
yeah, absolutely. I think that's it. I think there's probably a couple more questions, but I think you guys have
Thank
been.
you all so much for coming and for your attention and all the excellent questions and participation. We really appreciate it.
Yeah, you can, if anybody has any follow-up questions, like, I'm sure you can reach out to the Pinecone team. You can also reach out to me on Twitter at Netloop. I'm happy to answer any questions via DMs.
Awesome. Thanks so much, Hassan. And we'll see everybody around. We'll have the recording out for you shortly.
Thank you.
Bye-bye.